Okay, in this next question, we're going to consider two lines. So the first line, L1, let that be the line through the point 21 and the point 34. And let L2, the second line, that's going to be the line through 21 again, and then a new point, 310. So which line has larger slope? Well, we were not really asked to draw the picture, but I wanted to do that. So you'll see here L1 going through 21 and 34, and you'll see L2 going through 21 and 310. And we can just compute the slopes, all right? So it's worked out here in some detail, but in simplified form, L1 has slope 3 and L2 has slope 9. So which line has larger slope? Well, certainly L2 has larger slope than the number 9 is bigger. But the thing to really notice about this is that the steeper line has larger slope. All right, L2 in the picture looks steeper than L1 does. So why do we discuss slope? Well, it helps us to talk about the shape of graphs later on that are not quite lines. You need slope in college algebra to talk about rate, especially in word problems. This linear idea of what's going on with rate is important to talk about what's really happening in a lot of word problems. In another math class that follows after college algebra, in trigonometry, you need slope to talk about tangent, and you need slope in calculus to talk about the derivative. You need slope in chemistry to talk about reaction rate. I asked a microbiologist, and slope is actually going to be necessary to talk about a thing called linear regression. There's actually a lot of places that slope actually appears. And I have the following expectation, and actually all of the things that I just listed above, even if you wouldn't take some of those classes in the future, and you never know, but all of the reasons above are all the applications of slope listed above are good reasons to have this expectation. And here's the expectation. It's actually kind of a multi-part expectation. So I want you to be able to do this. So if a line is drawn, if you just see me draw a straight line, or somebody draws a line for you, I want you to recognize, without doing any computation, whether the slope is positive, negative, 0, or undefined. So of course, there's a slope formula, but I mean, sometimes you need to compute the slope exactly, all right? Then you need the formula. But without using the formula, if you just look at a line, can you tell if a line has positive slope versus negative slope? And that's what the first examples are really trying to dig into. What about 0 slope? That should be a completely horizontal line, right? Undefined slope, that should be a completely vertical line. And then, if you are given two lines that both have positive slope, I would like you to recognize without computation which line has larger slope. And that's why we talked about steeper lines, right? These should be done without computation. This should just be done by eyeballing it, just by looking. So interactive question, which of the lines here have positive slope? Okay, so there's a line that I've labeled A, one called B, one called C, one called D, one called E, and one called F. So which of these lines have positive slope? And then, it's not part of the interactive question, but on your own, you should just ask yourself, which of the lines here have negative slope, which have 0 slope, and which have no slope. Okay. All right, so that's the interactive question. Now, what I'd like to do is play a different kind of experiment here. So all the lines that you're going to see on this slide have positive slope. So, between A and B, which has larger slope? B has larger slope than A, right, because B is steeper. Between C and D, which has larger slope? C or D? Well, C has larger slope than D. What about E and F? Which has larger slope? E is actually steeper, so E has larger slope than F. What about G and H? Which has larger slope? This one's a bit of a trick question. They actually have the same slope. So I actually, for G and H, I just copy-pasted the same line, and I just replaced the label G with the label H.